This is lesson 4 from unit 7. I have a logarithmic function. There is no horizontal asymptote like we see in B, we see in C. And so for that reason, I know that I will have the basic parent function that has a vertical asymptote that corresponds with the y-axis. Sometimes students get confused and they think back to lesson 1 when we have exponentials. Remember, exponentials that have not been shifted left or right with a horizontal shift are going to have a horizontal asymptote that aligns to the x-axis. But with logarithmic functions, we are going to have a vertical asymptote that aligns with the y-axis. So let's choose a few numbers here, and then we can go about and doing B, C, and D accordingly. So let's go ahead and let's plug in 0. Now let's think about this. Let me grab a blank piece of paper to have more room. Let's go back here. We can see we are not allowed to use a graphing calculator, and I will graph each one of these according to this basic parent function, log base 3 of x. So I'm going to write this, and I'm going to change it into exponential form. The base is 3. I go across the equal sign. I raise up a y, and it equals whatever value is behind the base. So some students right away like to rewrite this. So we're going to write log base 3 of x. And instead of putting y equals on the left, they can put it on the right, and it's easier for them to go into exponential form. Again, how do we do that? It's going to be 3 raised to the y value equals x. And that allows us when we're plugging in numbers. So we're used to plugging in values for x. But now we can see that our input is actually going into the y. So I'm going to switch that and put a 0 in for y. 3 to the 0 corresponds to 1 because any value raised to the 0 power is 1. Let's do 1. Oh my goodness. 3 to the first power. 3 to the first power equals 3. And let's go ahead and do a negative 1. 3 to the negative 1. Well, 3 to the negative 1 means it is not happy being on top. So it is going to go to the bottom, which is the reciprocal, and we end up with 1/3. And we're going to refer to these 3 ordered pairs as we graph the next 3 graphs. So let's go ahead. I'm going to press pause. All right, I've graphed those 3 points. We can see as it moves to the left, it's getting closer and closer to this vertical asymptote, but it will never touch or cross it. And as it moves to the right, it is gradually going up. Now, how can I use this parent function as I look at the option B? So a couple things to think of. Whenever you have a negative in front of the log, we need to take that negative and we need to multiply it by the y value. So if I came up with values here, it's going to be 1/3 times negative 1 would be 1, and I have a 1 here, times negative 1, well, 0 times a negative is still 0, and we have 3 times a negative 1 is negative 3. Okay, so I've accounted for the negative sign in front of the log. Again, that negative sign is always going to impact our output values, the y's. This is going to shift this graph to the right 2 and up. Only horizontal asymptote we have continues to be this vertical asymptote, but instead of it being x equals 0 is the equation of the vertical asymptote. Now the vertical asymptote, it crosses the x-axis is x equals 2. Down here, by the way, in the previous problem, we had an x-intercept of 1, 0. Okay, so this is not an asymptote. This just helps me define what is my new origin, the new 0, 0. Once I know what my new 0, 0 is, I've shifted it to the right, just opposite of what you think, and up 1. Now I'm just going to use these points to graph. So I'm going to go to the right 1/3 and up 1. I'm going to go to the right 1 and at 0, and I'm going to go right 3, 1, 2, 3, and down 1. And we're able to see this translated function. Let's take a look at letter C, Okay, so letter C is looking different. Now, notice I do not have a negative up front, but there's a negative inside. A negative in front of an x is going to impact the y value. So I'm going to come over here and make my chart. This is the original. I have negative 1, 0, and 1. But now my x values, if there's a negative in front of the x, if I said it impacted the y's, the negative in front of the x behind the log, this will impact the x's. So I'm going to take this negative times 1/3 to get a negative 1/3. 1 times the negative is a negative 1. And 3 times the negative is negative 3. Negative in front impacts the y's. Negative inside impacts the x's. All right, so I've already used that. There's no other number like we can see in option D. So I'm not shifting this to the left and the right like I shifted to the right here. I'm not doing that, but I am shifting everything down too. So although this is my real vertical asymptote at x equals 0, I'm going to shift everything down too. Just like I shifted in the previous problem, everything up 1. So if I'm trying to identify where's my new origin as I graph this, this is my new origin. I went down 2. I still have the same vertical asymptote as the parent function. And now I can use these points. So I'm going to go to the left 1/3 and down 1. Left 1/3, down 1, left 1 and 0, left 3, 1, 2, 3, and up 1. Let me go. We can see now this is our new translated function. Again, this is like my new origin, and I can use these points accordingly. I'm going to come back and do the x-intercepts in just a little bit. I'm going to go over to part D. And again, as I go through them, I like to check them off to make sure I have accounted for all the translations. Whenever you see a negative inside the parentheses that is behind the log base, we have to, if there's any other numbers, like here, there's no other numbers inside parentheses, but we can see in part D there actually is other numerical values. So we have to go ahead and we have to factor out that negative sign. So I'm going to rewrite this as y equals negative log, and now I'm going to factor out the negative that's in front. Now, why didn't we do it here? Because there's no other values inside. And I'd be left with x plus 1. Now, it's late. Let's make sure I'm doing this right. I get negative x and negative 1. Perfect. So what's happening here? We're going to move this to the left one, and we're going to move it up 2. Let's go. All right, so we can see this is my vertical asymptote at x equals negative 1. This is not an asymptote. That's why I did it really light. This just allows us to see where is my new origin. I took the parent function, the 3-order pairs from the parent function. As you recall from part B, when there's a negative in front, we're going to take that negative 1 times the y value. So times negative 1 times negative 1 times negative 1. Now the negative sign behind the log base 3, the negative sign behind the log base 3 is going to be multiplied by the x's. Negative, negative, and negative. And now from this point, I'm going to go ahead and graph. So I'm going to go to the left 1/3 and up 1. I'm going to go to the left 1 and 0. And I'm going to go to the left 3, 1, 2, 3, and down 1. And we can see it's going in this direction and then up towards the asymptote. Okay, let's now look at identifying. When we identify the x-intercepts, we can see this is the obvious, right? We can see, well, I already identified it just up above, but how do we algebraically do it when it doesn't show up? What do we need to do? We don't want to estimate, we want an exact answer. I'm going to take the original function, and whenever I identify an x-intercept, y is always 0. So 0 equals negative, and that's like a negative 1 log base 3 of x minus 2 plus 1. And now I want to go about solving this for x. So how do I solve this for x? Give me 1 second. Okay, I want to get this portion by itself. I'm doing PEMDAS backwards. First, I am subtracting to get negative 1 equals negative 1 log base 3 of x minus 2. I'm dividing by negative 1. 1 equals log base 3 of x minus 2. And now some students like to write like this. Other students want to rewrite it and put the equal sign and the 1 on the other side. I'm at this time going to put this into exponential form. My base is 3. I go across, raise up to a 1, equals x minus 2. Well, 3 to the first is 3. And when I add 2 to the other side, I get an answer of 5. Let's see if that looks about right. 1, 2, 3, 4, 5. Yeah. So this is 5, 0. let's go ahead and look at part C. Same concept. I'm plugging 0 in for y. I have log base 3 of negative x, subtract 2. Okay, I'm going to first add to the other side. 0 plus 2 is 2. And a lot of students do like or do prefer to have the equal sign and then 2 on the other side. And now I'm going to go about, let me grab a pen here. I'm going to write it in exponential form. So 3 raised to the second power equals negative x. That'd be 9 equals negative x. And when I divide both sides by this negative 1, I get x equals negative 9. X equals negative 9. Okay, well, let's take a look at this problem. Would that be correct if I did it? So it looks like maybe I went up a little too fast. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Way over here is it's going up really slow. It looks like eventually we'll cross the x-axis way out at negative 9, 0. So negative 9 and 0. Okay, let's take a look right now at part D. I'm just going to flip this around and go about doing the same thing. I'm setting y equal to 0, negative 1 times log base 3 of negative x minus 1 plus 2. First, I'm going to subtract 2 to the other side. Negative 2 equals negative 1 times log base 3 of negative x minus 1. I'm going to divide by negative 1 to get 2 equals log base 3 of negative x minus 1. And now I'm going to write it in exponential form off to the side. So again, some students like to put the equals 2 on the other side. So 3 raised to the second equals this quantity. 3 raised to the second equals this quantity. 3 squared is 9. I'm going to add 1 to the other side. And I get 10 equals negative x. Dividing by negative 1, I get x equals negative 10. Let's see if that looks about right. Again, I think I started this downward swing just a little bit too fast. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 will be somewhere way over here. And so eventually it's going to cross.